Great. Thank you for those who are here, and thanks to those watching the recording. I'm Jonathan Eckman. I'll be presenting the Regional Energy Independence in Northern California and Alternative Energy Analysis. I'd like to thank our group's manager, Claire, and deputy manager, Maya, as well as our faculty advisor, Professor Hill, and the full team for all of their support throughout this semester. So just quickly for our agenda for this presentation, I'll be going over the client that we're working with, as well as the research question and the problem at hand. And then I'll be getting into our research topics, some of the challenges that are part of this problem, as well as our methodology and the next steps throughout the course of this semester. So the client that we're working with is the Pacific Forest Trust. They're not-for-profit based in San Francisco, California, and their mission is to sustain America's forests for the public benefits of wood, water, wildlife, and people's well-being. You can see here on the slide, there are kind of 4 pillars of their work. And overall, their goal is to manage forests in Northern California to make sure that they're protected, especially from the increasing threat of wildfires. So the research question that we're dealing with is, can the region that you can see here on the right utilize local woody biomass for its energy supply? The corollary question to that is, will this adequately enhance forest health while minimizing fire risk? You can see here on the right-hand side of the screen the region that we're talking about. So this is a 9-county region in Northern California. This region is mostly forested and largely rural, so it's very much different from kind of the typical elite areas of Central and Southern California. We'll get into more about why we're discussing biomass, energy, and wildfires kind of all at the same time over the next few slides. So the core problem is wildfires. Of course, California is known for its ever-present but also increasing risk of wildfires. And wildfires are a problem because they lead to a loss of forests and the ecosystem services that they provide. And they also lead to a loss of power, as we'll get into, as well as property and human life. There are a few main causes of wildfires that we'll be addressing today. One is a history of fire suppression in California. Next is climate change. And lastly, dangerous transmission infrastructure. Here we're talking about mostly electrical transmission lines. The Camp Fire and Carr Fire, both in 2018, are on CAL FIRE's list of the most destructive wildfires in California history, and both of these are in our region here in Northern California that we're talking about. You can see on this slide some of the staggering statistics of the damage that these fires have caused in terms of the number of acres burned, the properties destroyed, as well as the deaths caused by these. But these are just 2 wildfires and a problem that is very, very large and continues to be growing. For example, between 2013 and 2018, over 5 million acres burned in California in wildfires, and that's 5% of the state in just a 5-year period. Furthermore, 13 of the 20 most destructive wildfires of the last 20, have been since the year 2000, meaning that this is not a new phenomenon in California, but it is an increasing problem and an increasing threat. I mentioned a couple slides ago the history of fire suppression. We'll get into more on that here with this slide. So typically, you would have the surface fuel level at the bottom, which is the understory, and the tree crowns, or the overstory. But what happens with intentional fire suppression is that that latter fuel level gets built up over time, because typically a fire would start at the surface fuel level and then kind of fizzle out. Often the trees at the tree crown level are much more fire resistant, so typically it doesn't go beyond that, and the fire kind of stops on its own. With intentional fire suppression, that latter fuel level grows over time and literally creates the ladder for fires when they start at the surface fuel level, and that brings them all the way up to the crown level, which is what causes those very destructive and widespread wildfires. Another component of this is climate change. So as the area continues to get drier and hotter, that means that these fires are burning larger and hotter. That's because as more water is sucked out of the trees, they are able to catch fire more easily, and that also leads them to burning hotter as well. Another component of the problem that I mentioned is dangerous transmission infrastructure. So 5 of the 10 most destructive wildfires in California have been attributed to PG&E. That's Pacific Gas and Electric, which is the major utility in California that controls more than 70% of the electrical transmission lines in this region. They've completed only 30% of the required tree trimmings in 2019. So there's a problem that we are aware of, that is vegetation around these lines. It is an expensive problem. Clear cutting around those lines would cost anywhere from $75 to $150 billion to clear the vegetation around them. And it's a problem because often these lines, for one, they're typically very old, and they can snap and spark, igniting these fires. Also, the poles here that you see on the screen can fall over due to high winds, or trees can fall on the poles and knock them over. And that's what often ignites these fires at the surface fuel level, and then that extends up to the tree crowns, and we saw on the last slide. So now I want to bring it back to the question of biomass, which is really the key thing that Pacific Forest Trust has tasked us with looking at. The question is, can we take that abundant ladder fuel material, which we're considering woody biomass from the forests, and use that for electricity generation? Doing so would remove that fuel from the forest, meaning that forests would be less fire prone. It would also mean that we're providing a renewable source of electricity rather than relying on natural gas or other fossil fuels. So some of the questions we're looking at are whether and how the grid can be integrated between biomass facilities and traditional electricity generation, how much fuel in terms of that woody biomass is available, how the forests can be managed more sustainably so that they're healthier. And we also have to consider the cost of biomass, both in terms of the cost of the facilities, but also the cost of transporting the material from one place to another. Another important factor is net emissions. So often in wildfires, of course, that wood is just burning. The carbon held within that wood is being released into the atmosphere. In 2018, for example, the wildfires in California released as much carbon dioxide into the atmosphere as the entire electricity sector combined in just a single year. So the idea is that instead of letting that wood just burn in wildfires, we could burn it in a controlled way in a biomass facility, and you create electricity from that, thereby kind of mitigating some of the traditional electricity generation from fossil fuels. In terms of our methodology with this analysis, we have a few key kind of ways that we're doing this. So one is interviewing energy and forest management experts. We've interviewed experts for the California Energy Commission, as well as the California Natural Resources Agency. We are also collecting energy data and analyzing that on our own for environmental and financial impacts. And we are overall conducting a feasibility analysis based on case studies and the data and the experts that we're talking to. We're also posing questions for further research for our client, Pacific Forest Trust, to take after the semester. Of course, we realize that we can't accomplish everything that would be necessary for this study in one semester, so we're just posing further questions that need to be addressed. Some of the key questions that have led to some of these key metrics on the right-hand side of the screen are how much electricity the region consumes. This is just an important baseline or benchmark to understand if this is actually feasible. We found that to be 5,000 gigawatt hours a year of electricity. The second question is how much electricity does biomass produce, to be able to compare that to how much the region needs. And our research shows that 1 bone dry ton, which is the typical unit for this type of biomass, produces 0.001 gigawatt hours of electricity. That means that we would need 5 million bone dry tons of woody biomass to produce the electricity necessary. Then the question becomes whether this is sustainable for the forests in Northern California. And lastly, just to go over some of the tasks that we have already completed and still need to complete throughout the course of this semester, we've submitted the project control plan and the literature review methodology to our client. Some things that are ongoing on a weekly basis are interviews that I mentioned, as well as our research and our environmental and financial analyses. The preliminary report will be submitted this Friday in 2 days, and our final briefing and final report will be submitted later on this semester. We also have a weekly task, which is a call and report to our client, just to make sure that our client is kept updated on our progress. Great. Thank you for your time, and I'm happy to take any questions offline.